The most common photoinitiators used in resin printing seem to be in the phosphine oxide family. These seem to have the reaction properties that are good for the types of acrylic resins that we use. There seem to be two main families of phosphine oxide initiators, TPO and BAPO. TPO is identified by having an extremely clear color. And if you read documentation from various coatings manufacturers, when you are making clear coatings, TPO is the recommended initiator for that. PR48 is known to use TPO as its initiator since their formulation is online on the internet. And this resin is very, very clear. I'm going to dispense now 15 milliliters approximately of PR48. But you rarely find resins this clear. I order most of my resins in unpigmented, so I can pigment them myself. And PR48 is by far the clearest. That and the full spectrum laser clear is also pretty clear. Most other resins are not nearly as clear. So here I have the Fun to Do industrial blend. Let me dispense some of this out. Also 15 milliliters. I want to measure them out since I'm going to do a variety of additive experiments. And you can see that the clearness of the transparency of these two is not the same. If I put maybe a piece of white paper here for us to look at, even at this distance, you should be able to see that the PR48 is more clear than the Fun to Do. That the Fun to Do is somewhat yellowish. I can bring this up a little bit closer, and then you can see the difference here and the difference here, right? And this is because I think that most other resins use BAPO as their initiator. BAPO is well documented in guides from coatings manufacturers as being very efficient. A given amount of photoinitiator initiates a lot more curing with a given unit of BAPO compared to TPO, especially for near UV and visible light wavelengths, near UV being like 365 nanometers and above. Most professional UV curing that is LED based is 365 or 395 nanometers. And there's also a lot of marketing materials about this because a lot of coatings houses have been switching from mercury vapor lamps or mercury lamps to LEDs because they're more power efficient. So there's a lot of documentation, marketing materials about how different photoinitiators perform using LED light. And so the recommendations from manufacturers for people switching to LED light is to use BAPO unless you need clear, in which case use TPO. So while I don't know for sure what's in Fun to Do, based upon the curing spectra that they document on their site, that curing spectra matches the documented absorption spectra of BAPO, which essentially can absorb light up to about 420 with some peaks in the 360 range and then another small peak around 405. Both of these are reactive at 405, but this guy has reached way its kind of tail end by the time you hit 405. This guy actually has a decent peak at 405, and it'll keep going to about 420. And so the question with these is, can I print clear? Meaning, what do I need to do in order to print a totally clear part? Or not totally clear, but as clear as possible. So even if it's a little bit yellowish, I'll take what I can get. And there's a lot of different possibilities to this, especially if you get into using LED-based setups. So first, just kind of some of the basic differences between these two. We have in the PR48, there's already a UV dye in it. They put Mayzo OB, which I sourced from them, or from Mayzo, is a commercial sample. And that dye is already incorporated into PR48, whereas most other unpigmented resins are totally undyed. So there's no dye in here. Right? So let's first take a look at what the differences are at different curing spectra. I have here, this is a 420 nanometer laser pointer. You can see here kind of the laser light. And then this is a 405 nanometer laser pointer. You can see that's a little bit brighter, right? If I compare the 420 to 405, the 405 looks it's a bit brighter, but it's also a bit more violet. And then I have here a 365 nanometer UV flashlight. And these are lasers, right? So lasers are single wavelength. This is a LED. LEDs are not single wavelength, but they have very, very sharp peak at the peak level. In this case, the 365 nanometer level. The peak here is very sharp compared to a mercury lamp, which has very wide distribution. And so while this is not quite the same as a laser, and similarly, this 405 is not going to be a substitute for, say, a 405 nanometer LED, which I don't have a flashlight for. I ordered one, and hopefully I'll do an update when I try with that. And so let's just first take a look at the differences in curing behavior. Let me mark here on the sheet just so that we're clear what we have. This is what I believe is BAPO on this side, and what I believe is TPO on this side. So let's start with what is the behavior under 420 at 420. So I'll dispense a little bit up there, and then I'll dispense a little bit, a couple of drops here. All right, and then let's hit this with the 420. So I'll first hit this guy with the 420. Let me move, just so I don't have any accidents illuminating this resin. I'll move them further away. Take the 420, and then I'll hit this guy with the 420 also. All right, what happened? Let's take a look. So let's start with the BAPO. 420 had no effect. And the TPO, 420 had no effect, not cured at all. And so remember I said that this guy tails off at 420, this guy even earlier than that. So it looks like 420 is just not enough. It's just not high enough of a wavelength to cure anything. Now let's give it a shot with 405 and see what happens. So I'll hit this guy with the 405. There's a little smoke rising out of this, and that indicates that there's a curing reaction going. And then let's take this guy. You can see that there's a significant fluorescence in here. That's the dye. So we are activating the dye here, and there's a significant curing reaction here as well. So both of these guys react under 405. Let me make sure this is completely cure, and then we'll compare the difference between these two. All right. So let's start with the BAPO, and it cured, from what I can tell, it cured quite hard, and it probably cured all the way through because it's adhered to this way boat. Yeah, so totally cured through. That means that if I measured this, the minimum cure distance here, it cured all the way through completely, so it's totally flat on the other side. There's no liquid left. And that is half a millimeter. And that means that, given that there's no pigmentation in here, 405 will cure to at least half a millimeter depth, if not further. Which is fine. What it means is that you would never print at half millimeter layer height. And so for all intents and purposes, this is going to blob up insanely when you print, because it's going to penetrate a lot of layers through. Now let's take a look at the TPO. And that's kind of interesting because it didn't cure all the way through in the middle. So this has a kind of a blob shape. It's shaped like a drop, which is the curved shape of the drop as it came up. And the bottom side also has a drop-like shape. Let me clean this up a bit. In the back. That means that at 405, given that there's a dye, there is a maximum cure depth. It won't cure an unlimited amount. It won't go all the way through. Let's see if I can get a measurement of some of the edges here. So that's like 0.3. Difficult for me to get a maximum thickness, but it looks like definitely there's a limit. The limit here seems somewhere around half a millimeter to 1 millimeter, something like that. It's less than a millimeter thick, so probably around half a millimeter or so. But clearly there's a difference. So 405 will cure both, but it cures through this one much better. But remember, there is blocking dye in here. There's no blocking dye in here. So let's put these aside and let's do one more test before I start messing with the mixture, and that is to look at the difference in behavior at 365. So let me take a small drop here. Then let's also dispense a small amount here. And let's hit it with the UV light. I'm going to try to shine it this way. So this is 365. I'm testing here full cure here, so I'm going to keep going until I don't see anything change. That's done. And then 365 here. See, there's a lot less fluorescence. There's no dye in here, so it doesn't fluoresce. It does yellow. So as it cures, the BAPO, the fun to do side, becomes more yellow. Let's see what this looks like now. So this did cure at 365. This cured, and cured all the way through because it's still pretty pretty stuck to this. Oops, that broke off, but I couldn't get this off in just one piece. But it is stuck on, and it cured all the way through. It's 0.5 millimeter, so I dispensed randomly about the same amount. And then on this side, it clearly did not make it all the way through. So there is a very thin layer at the top, but it's still wet through, and I shined it for quite a while. So interestingly, at 365, the maximum penetration is fairly shallow. If I just squish this down, it's a little rough, but this is 0.35, and there's still some wet stuff left on top. And so we would say that the maximum penetration of the PR48 365 is pretty shallow. So that was interesting. Let me discard these. Okay. So what does that tell us so far? Between 420 won't cure anything. It's way too far off the edge here. You can through cure anything, given that there's no pigment in here. And something about either the TPO or the dye, some combination, means that the maximum depth of cure with the PR48, the TPO, is much less. And the question is then, how much of this effect is the photoinitiator versus the dye, some combination thereof? And we can test this. Because I have some OB, I can dispense some and make a blend that also has some dye in it. The dye concentration is documented. I think it's something like 0.1%, somewhere between 0.01 and 0.1%. I don't remember the exact degree. I'm going to dispense 0.01. So this is 15 milliliters. The specific gravity here is close to one, something like 1.1. So that's 15, and then 1.5, 0.15, 0.015. So I want to get 0.015 grams dispensed in here. Oops. Very aggressive timeout. All right. What? All right, we're back. Ran out of batteries. I want a small amount, 0.015. All right, that seems fairly close. It's difficult to measure such small amounts, but this seems to be about right. So let's get that off. Put that away. Okay. OB is pretty soluble, so I should So let's try this again. Now there is UV dye in there. Let's see what the difference is. That guy's busted. Just as well. All right. A small amount on here. Let's take a look at what happens when I do the 405. Go back to the replay, but it looks like there's more fluorescence. Spotty. Dye may not be fully incorporated since it looks kind of spotty in there. And this also that cured all the way through. Yeah. Okay. Don't know where that went, but that clearly cured all the way through. So pretty much with the dye, no difference unless I made a mistake. Easily possible I didn't stir this enough. So maybe we okay. So in reality, this Mayzo OB is UV dye. So in theory, it is actually not effective at, not really effective at 405. So that behavior is not that unexpected. I'll try it again just to make sure I didn't make any serious error. Let's see what this looks like now. Maybe bubbles, smoking. Nothing wet left, so that pretty much still cured all the way through with the 405. Alright, now let's see whether there's any difference with the 365. Oh, interesting. At 365, it did not cure all the way through. It's still wet at the bottom, kind of like the PR48 was. That's interesting. That means that this UV dye does without affecting the color does block the 365, whereas the 405 had no effect. Kind of cured all the way through in 405 like it did before. But at 365, it did not. Let's try this again. Okay. Oh yeah, that is quite wet underneath at the bottom still. That's interesting. Okay, that is interesting. So now what I want to test is what the maximum cure depth is. So to test the maximum cure depth, I'm going to actually need to put enough into the weigh boat on the other side that it'll be a fully solid layer, and then we'll compare the thicknesses. So rather than allowing the just putting a droplet in and trying to measure the droplet, I'm going to put a couple of milliliters into the weigh boat and measure the outcome. So let's try half a milliliter, and then another half a milliliter. Okay, so that's 1 milliliter. And then I want 1 milliliter of PR48. Fully coat the surface at the bottom, and let's see the difference. So let's start with 365. And then we'll try 365 here. Okay. Definitely we cured some of the top, and we can pull off a film. So it did not cure all the way through. We'll measure that in a bit. Now let's grab this. This also did not cure all the way through. It's noticeably thinner. All right. Noticeably thinner. All right, let's measure this. The thickness of the PR48 is 0.1. So that means even when dousing it with a flashlight, maximum thickness 0.1. And here the maximum thickness is 0.22. But the interesting thing is it did have an effect. So now I want to do a validation, right? So the question here is, since I did it this way, if I did not put any dye in at all, is the thickness here because of the dye, or is it because of just natural characteristics of the resin? Now I'm pretty certain that it's the dye at the 365 level, and we can test that by, let me move this over, dispensing a milliliter of another dropper. Dispense a milliliter of the unadulterated stuff. This is pretty hard. Let me dispense some into this white boat here. There we go. And then I'll grab a milliliter out of it. Just half. And then 1 milliliter here. I got bubbles in there. All right, let me put this off to the side. Okay. I got bubbles again. Okay. So this is the unadulterated stuff, 365. I'll move these off to the side. Okay, so this didn't cure all the way through either, which is interesting. And then, how thick is this? So this still maxed out at 0.2 millimeters deep, as if the dye really had no effect, which is possible. It's possible that the dye is just not soluble enough in this resin, or that there's a step that Autodesk didn't document to get the dye fully incorporated. I'm not exactly sure. So the last step is to, and this could take this a bit longer, is to see what the depth of cure at 405 is. Then since this is a laser, I have to sweep the surface, and this could take some time. So I'm sweeping the surface now of the PR48. Now let's sweep the surface of the undyed fun to do. This is giving off a noticeable odor when I'm doing this that I didn't get with the PR48. And then the dyed let's do another quick pass here. It's really, there must be a lot more dye than I thought. Maybe this is, instead of 0.01, 0.1, 10 times as much. I mean, the level of fluorescence here is just so much more. There's definitely more fluorescence on the dyed one, but not nearly as much as on the undyed. All right, so let's see what the difference in 405 was. 405 didn't get all the way through. So 405, though, this definitely got deeper than 365. So at 405, this is about 0.55, 0.6 millimeters thick. And previously that was only 0.1 with the 365. This guy, maxed out. Yeah, pretty much maxed out. Almost nothing left down there. So that's like, what, 1.2 millimeters, more than a millimeter. And then this guy also seems like it maxed out. Yeah. There's spots there that got all the way through. About a millimeter. Yeah, so it got all the way through. But the difference in fluorescence is interesting. I wonder if I simply need more. Instead of 0.015, 0.15. So let's try that and dispense out another quantity. All right, just so we're clear, this is also BAPO here. This has dye, and this has no dye in the middle. Okay. Need the way this again. Let's turn this on. To lay down a piece of weighing paper. And now I want to add in 0.15, about 0.14 this time. .131, or really like 0.135. There we go. Close enough. dye concentration, I got a millimeter. So the net is that solid dye is tricky. And at 405, everything just cures deeper. All right, one more trial. And that is, apparently this stuff is soluble, or the OB, yeah, it's settling out here. So this did not dissolve. So that's of course no good. That kind of invalidates the test. Let us, however, turns out that this OB is soluble in ethyl acetate. Which is glycol ether. So let me put some in here. Now this is going to be totally useless for printing. This is going to make this way too weak. That will hopefully dissolve some of this. I might have to mix up a new batch if this doesn't do anything. Okay. And then okay, let's first start with 365, see if that makes any difference. Let's see what this looks like. Thinner. Oh, still 0.2. But I should have dissolved it first. And then yeah, I don't think this is going to create a change. This looks about the same. I'm in a 405. .5 does seem to have a positive effect at 405, since previously 405, this guy's like super thick. This isn't nearly as thick. The effect is not as profound as I thought it should be, and I'm a little bit. It seems weird that it has no effect, no difference at 365. This either means that the blockage by the photoinitiator is what makes the biggest difference, or I really, have a mixing problem. So let's try this again. Let us mix up a small batch of All right, so that's 5 milliliters of glycol ether. Oh, I don't have anything small enough to stir this tiny beaker. Yeah, that's a little weird. I need something real small. All right, a little bit of PLA. So what is it supposed to be? 2%. So 5.1. All right. I'm gonna wing it a little bit. This is less than point. That's less than 0.1. Let's first see if that will actually dissolve in this. Theory, if this dissolves, then the solution should fluoresce rather than spots fluoresce. Let's see here. Well, first I need some comparison. So how does it fluoresce look when I shine it from the top here? Versus fluorescing? I don't know. I mean, that certainly fluoresces. Is the solution fluorescing? Kinda looks like from the top that it is. Well, there certainly are a lot of undissolved bits. Let's put a little bit more in. 0.1. Dissolve and then pour it off the top. Alright, that's probably all that's going to go in. Let's start this thing up. Okay. Sorry, still stirring. Still stirring. All right. Getting a little clumps out is a bit of a challenge. All right, let's see here. Does this thing fluoresce? It does fluoresce. Is it dissolved? I don't know. That's pretty bright, kind of like reflects off the way that it reflects off the top here, as opposed to, yeah. Yeah, so it's more similar to what goes on in the PR48. Compared to the undyed, but this stuff is just, yeah, I don't know. All right. Then I'll put a little bit. Mix a little bit in here. How much? A very, very small amount. 1 milliliter in here. So you need about 1/10 of a milliliter. 1/100th of a millimeter. It's like 1 drop. Maybe it's a little bit more than 1 drop. Five drops. All right. So this has the Mayzo OB kind of dissolved in glycol ether first. And this does not fluoresce the way that it does. So first we're trying with the 365. There should be enough left over for me to do the 405 underneath it. So this is what point 2 is the depth that we got before. And this is 0.2, so pretty much the same. And then the depth with the laser. This at full cure is over a millimeter when it's undyed. The fluorescing is just not as much as I would expect. Yeah, I'm expecting a lot more fluorescing if this were working, which it's not, so it's probably not working. It feels pretty thick. That's pretty warm too. 0.9, that's within, I mean, it's about a millimeter. It's about the same. All right, so what if I put another 5 drops? Stir up the remnant here. This probably has so much solvent in it that it might not cure at all. Let's see what the fluorescing behavior is. Really not fluorescing as much as I expect it to be. All right. It's not as weak as I thought it would be, given how much solvent there is in there, but this is still at about, a millimeter. Maybe a little less, 0.6, hard to say. 0.6 or maybe. Solubility seems to be an issue. This actually might have a effect at 405, but it doesn't seem to have an effect at 365, strangely enough, even though that's the peak for this dye. And that may be because at 365, the dye doesn't make too much of a difference compared to the photoinitiator, but it made a difference for the TPO. The answer is I probably need to get some toluene, and since toluene is much more soluble, and then try that.